I'm reading Carl Sagan's Contact. We're on part 1, The Message. My heart trembles like a poor leaf. The planets whirl in my dreams. The stars press against my window. I rotate in my sleep. My bed is a warm planet. Marvin Mercer, PS 153, 5th grade, Harlem, New York City, New York, 1981. Chapter 1, Transcendental Numbers. Little fly, the summer's play, my thoughtless hand has brushed away. Am not I a fly like thee? Or art not thou a man like me? For I dance and drink and sing till some blind hand shall brush my wing. William Blake, Songs of Experience, The Fly, stanzas 1-3. By human standards, it could not possibly have been artificial. It was the size of a world. But it was not so oddly and intricately shaped, so clearly intended for some complex purpose, that it could only have been the expression of an idea. Gliding in polar orbit about the great blue-white star, it resembled some immense imperfect polyhedron encrusted with millions of bowl-shaped barnacles. Every bowl was aimed at a particular part of the sky. Every constellation was being attended to. The polyhedral world had been performing its enigmatic function for eons. It was very patient. It could afford to wait forever. When they pulled her out, she was not crying at all. Her tiny brow was wrinkled, and then her eyes grew wide. She looked at the bright lights, the white and green-clad figures, the woman lying on the table below her. Somehow familiar sounds washed over her. On her face was an odd expression for a newborn, puzzlement perhaps. When she was 2 years old, she would lift her hands over her head and very sweetly say, "Dada, up." Her friends expressed surprise. The baby was polite. "It's not politeness," her father told them. "She used to scream when she wanted to be picked up. So once I said to her, 'Ellie, you don't have to scream. Just say Daddy up.' Kids are smart. Right, Presh?" So now she was up all right, at a giddy altitude, perched on her father's shoulders and clutching his thinning hair. Life was better up here, far safer than crawling through a forest of legs. Somebody could step on you down there. You could get lost. She tightened her grip. Leaving the monkeys, they turned a corner and came upon a great spindly-legged, long-necked, dappled beast with tiny horns on its head. It towered over them. "Their necks are so long, the talk can't get out," her father said. She felt sorry for the poor creature, condemned to silence. But she also felt a joy in its existence, a delight that such wonders might be. "Go ahead, Ellie," her mother gently urged her. There was a lilt in the familiar voice. "Read it." Her mother's sister had not believed that Ellie, age 3, could read. The nursery stories, the aunt was convinced, had been memorized. Now they were strolling down State Street on a brisk March day and had stopped before a store window. Inside, a burgundy-red stone was glistening in the sunlight. "Jeweler," Ellie read slowly, pronouncing 3 syllables. Guiltily, she let herself into the spare room. The old Motorola radio was on the shelf where she remembered it. It was very big and heavy, and hugging it to her chest, she almost dropped it. On the back were the words, "Danger, do not remove." But she knew that if it wasn't plugged in, there was no danger in it. With her tongue between her lips, she removed the screws and exposed the innards. As she had suspected, there were no tiny orchestras or miniature announcers quietly living out their small lives in anticipation of the moment when the toggle switch would be clicked to on. Instead, there were beautiful glass tubes, a little like light bulbs. Some resembled the churches of Moscow she had seen pictured in a book. The prongs at their bases were perfectly designed for the receptacles they were fitted into. With the back off and the switch on, she plugged the set into a nearby wall socket. If she didn't touch it, if she went nowhere near it, how could it hurt her? After a few moments, the tubes began to glow warmly, but no sound came. The radio was broken and had been retired some years before in favor of a more modern variety. One tube was not glowing. She unplugged the set and pried the uncooperative tube out of its receptacle. There was a metallic square inside, attached to tiny wires. The electricity runs along the wires, she thought. vaguely. But first it had to get into the tube. One of the prongs seemed bent, and she was able after a little work to straighten it. Reinserting the tube and plugging the set in again, she was delighted to see it begin to glow, and an ocean of static arose around her. Glancing towards the closet door with a start, she lowered the volume. She turned the dial marked frequency and came upon a voice talking excitedly, as far as she could understand, about a Russian machine that was in the sky, endlessly encircling the earth. Endlessly, she thought. She turned the dial again, seeking other stations. After a while, fearful of being discovered, she unplugged the set, screwed the back on loosely, and with still more difficulty lifted the radio and placed it back on the shelf. As she left the spare room, a little out of breath, her mother came upon her and she started once more. "Is everything all right, Ellie?" "Yes, Mom." She affected a casual air, but her heart was beating, her palms were sweating. She settled down in a favorite spot in the small backyard, and her knees drawn up to her chin, thought about the inside of the radio. Are all those tubes really necessary? What would happen if you removed them, one at a time? Her father had once called them vacuum tubes. What was happening inside a vacuum tube? Was there really no air in there? How did the music of the orchestra and the voices of the announcers get in the radio? They liked to say on the air. Was the radio carried by the air? What happens inside the radio set when you change stations? What was frequency? Why do you have to plug it in for it to work? Could you make a kind of map showing how the electricity runs through the radio? Could you take it apart without hurting yourself? Could you put it back together again? "Ellie, what have you been up to?" asked her mother, walking by with the laundry for the clothesline. "Nothing, Mom. Just thinking." In her 10th summer, she was taken on vacation to visit 2 cousins she detested at a cluster of cabins along a lake in the northern peninsula of Michigan. Why people who lived on a lake in Wisconsin would spend 5 hours driving all the way to a lake in Michigan was beyond her, especially to see 2 mean and babyish boys, only 10 and 11, real jerks. How could her father, so sensitive to her in other respects, want her to play day in and day out with twerps? She spent the summer avoiding them. One sultry, moonless night after dinner, she walked down alone to the wooden pier. A motorboat had just gone by, and her uncle's rowboat, tethered to the dock, was softly bobbing in the starlit water. Apart from distant cicadas and an almost subliminal shout echoing across the lake, it was perfectly still. She looked up at the brilliant, spangled sky and found her heart racing. Without looking down, with only her outstretched hand to guide her, she found a soft patch of grass and laid herself down. The sky was blazing with stars. There were thousands of them, most twinkling, a few bright and steady. If you looked carefully, you could see faint differences in color. That bright one there, wasn't it bluish? She felt again for the ground beneath her. It was solid, steady, reassuring. Cautiously, she sat up, looked left and right, up and down the long reach of lakefront. She could see both sides of the water. The world only looks flat, she thought to herself. Really, it's round. This is all a big ball, turning in the middle of the sky once a day. She tried to imagine it spinning with millions of people glued to it, talking different languages, wearing funny clothes, all stuck to the same ball. She stretched out again and tried to sense the spin. Maybe she could feel it just a little. Across the lake, a bright star was twinkling between the topmost branches. If you squinted your eyes, you could make rays of light dance out of it. Squint a little more, and the ray would obediently change their length and shape. Was she just imagining it, or? The star was now definitely above the trees. Just a few minutes ago it had been poking in and out of the branches. Now it was higher, no doubt about it. That's what they meant when they said a star was rising, she told herself. The earth was turning in the other direction. At one end of the sky, the stars were rising. That way was called east. At the other end of the sky, behind her, beyond the cabins, the stars were setting. That way was called west. Once every day, the earth would spin completely around, and the same stars would rise again in the same place. But if something as big as the earth turned once a day, it had to be moving ridiculously fast. Everyone she knew must be whirling at unbelievable speed. She thought she could now actually feel the earth turn, not just imagine it in her head, but really feel it in the pit of her stomach. It was like descending in a fast elevator. She craned her neck back further, so her field of view was uncontaminated by anything on earth, until she could see nothing but black sky and bright stars. Gratifyingly, she was overtaken by the giddy sense that she had better clutch the clumps of grass on either side of her and hold on for dear life, or else fall up into the sky, her tiny tumbling body dwarfed by the huge darkened sphere below. She actually cried out before she managed to stifle the scream with her wrist. That was how her cousins were able to find her. Scrambling down the slope, they discovered on her face an uncommon mix of embarrassment and surprise, which they readily assimilated, eager to find some small indiscretion to carry back and offer to her parents. The book was better than the movie. For one thing, there was a lot more in it, and some of the pictures were awfully different from the movie. But in both, Pinocchio, a life-sized wooden boy who magically is roused to life, wore a kind of halter. There seemed to be dowels in his joints. When Geppetto is just finishing the construction of Pinocchio, he turns his back on the puppet and is promptly sent flying by a well-placed kick. At that instant, the carpenter's friend arrives and asks him what he is doing sprawled on the floor. "I'm teaching," Geppetto replies with dignity, "the alphabet to the ants." This seemed to Ellie extremely witty, and she delighted in recounting it to her friends, but each time she quoted it, there was an unspoken question lingering at the edge of her consciousness. Could you teach the alphabet to the ants? And would you want to? Down there with hundreds of scurrying insects who might crawl all over your skin or even sting you? What could ants know anyway? Sometimes she would get up in the middle of the night to go to the bathroom and find her father there in his pajamas, his neck craned up, a kind of patrician disdain accompanying the shaving cream on his upper lip. "Hi, Press," she would say. It was short for Precious, and she loved him to call her that. Why was he shaving at night when no one would know if he had a beard? Because, he smiled, your mother will know. Years later she discovered that she had understood this cheerful remark only incompletely. Her parents had been in love. After school she had ridden her bicycle to a little park on the lake. From a saddlebag she produced the radio's amateur handbook and a Connecticut Yankee in King Arthur's Court. After a moment's consideration she decided on the latter. Twain's hero had been conked on the head and awakened in Arthurian England. Maybe it was all a dream or a delusion, but maybe it was real. Was it possible to travel backwards in time? Her chin on her knees, she scouted for a favorite passage. It was when Twain's hero is first collected by a man dressed in armor, who he takes to be an escapee from a local booby hatch. As they reach the crest of the hill, they see a city laid out before them. "Bridgeport," said I. "Camelot," said he. She stared out into the blue lake, trying to imagine a city which could pass as both a 19th century Bridgeport and a 16th century Camelot, when her mother rushed up to her. "I've looked for you everywhere. Where aren't you where I can find you?" "Oh, Ellie," she whispered, "something awful's happened." In the 7th grade, they were studying pi. It was a Greek letter that looked like the architecture at Stonehenge in England. 2 vertical pillars with a crossbar at top. If you measured the circumference of a circle and then divided it by the diameter of the circle, that was pi. At home, Ellie took the top of a mayonnaise jar, wrapped a string around it, straightened the string out, and with a ruler measured the circumference of the circle. She did the same with the diameter and got, by long division, divided the one number by the other. She got 3.21. Well, that seemed simple enough. The next day, the teacher, Mr. Weisbrod, said that pi was about 22 divided by 7, or 3.1416. But actually, if you wanted to be exact, it was a decimal that went on and on forever without repeating the pattern of numbers. Forever, Ellie thought. She raised her hand. It was the beginning of the school year, and she had not yet asked any questions in this class. How could anybody know that the decimals go on and on forever? That's just the way it is, said the teacher, with some asperity. But why? How do you know? How can you count decimals forever? Miss Arroway, he was consulting his class list. This is a stupid question. You are wasting the class's time. No one had ever called Ellie stupid before, and she found herself bursting into tears. Billy Horstman, who sat next to her, gently reached out and placed his hand over hers. His father had recently been indicted for tampering with the odometers on the used cars he sold, so Billy was sensitive to public humiliation. Ellie ran out of the class sobbing. After school, she bicycled to the library at the nearby college to look through books on mathematics. As nearly as she could figure out from what she read, her question wasn't at all stupid. According to the Bible, the ancient Hebrews had apparently thought that pi was exactly equal to 3. The Greeks and Romans, who knew lots of things about mathematics, had no idea that the digits of pi went on forever without repeating. It was a fact that had been discovered only 250 years ago. How was she expected to know if she couldn't ask questions? But Mr. Weisbrod had been right about the first few digits. Pi wasn't 3.21. Maybe the mayonnaise lid had been a little squashed, not a perfect circle, or maybe she had been sloppy in measuring the string. Even if she'd been much more careful, though, they couldn't expect her to measure an infinite number of decimals. There was another possibility, though. You could calculate pi as accurately as you wanted. If you knew something called calculus, you could prove formulas for pi that would let you calculate it to as many decimals as you had time for. The book listed formulas for pi divided by 4. Some of them she couldn't understand at all, but there were some that dazzled her. Pi divided by 4, the book said, was the same as 1 minus 1/3 plus 1/3 minus 1/7, with the fractions continuing on forever. Quickly she tried to work it out, adding and subtracting the fractions alternately. The sum would bounce around from being bigger than pi over 4 to being smaller than pi over 4, but after a while you could see that this series of numbers was on a beeline for the right answer. You could never get there exactly, but you could get as close as you wanted if you were very patient. It seemed to her a miracle that the shape of every circle in the world was connected with this series of fractions. How could circles know about fractions? She was determined to learn calculus. The book said something else. Pi was called a transcendental number. There was no equation with ordinary numbers in it that could give you pi, unless it was infinitely long. She had already taught herself a little algebra and understood what this meant, and pi wasn't the only transcendental number. In fact, there was an infinity of transcendental numbers. More than that, there were infinitely more transcendental numbers than ordinary numbers, even though pi was only one of them she had heard of. In more ways than one, pi was tied to infinity. She had caught a glimpse of something majestic. Hiding between all the ordinary numbers was an infinity of transcendental numbers whose presence you would never have guessed unless you looked deeply into mathematics. Every now and then, one of them, like pi, would pop up unexpectedly in everyday life. But most of them, an infinite number of them, she remembered herself, were hiding, minding their own business, almost certainly unglimpsed by the irritable Mr. Weisbrod. She saw through John Stoughton from the first. How her mother could even contemplate marrying him, never mind that it was only 2 years after her father's death, was an impenetrable mystery. He was nice enough looking, and he could pretend, when he put his mind to it, that he really cared about you, but he was a martinet. He made his students come over weekends to weed and garden at the new house they had moved into, and then made fun of them after they left. He told Ellie that she was just beginning high school and was not to look twice at any of his bright young men. He was puffed up with imaginary self-importance. She was sure that as a professor he secretly despised her dead father, who had been only a shopkeeper. Stoughton had made it clear that an interest in radio and electronics was unseemly for a girl, that it would not catch her a husband, that understanding physics was for her a foolish and aberrational notion. Pretentious, he called it. She just didn't have the ability. This was an objective fact that she might as well get used to. He was telling her this for her own good. She'd thank him for it later. He was, after all, an associate professor in physics. He knew what it took. These homilies would always infuriate her, even though she had never before, despite Stoughton's refusal to believe it, considered a career in science. He was not a gentle man, as her father had been, and he had no idea what a sense of humor was. When anyone assumed that she was Stoughton's daughter, she would be outraged. Her mother and stepfather never suggested that she change her name to Stoughton. They knew what her response would be. Occasionally, there was a little warmth in the man, as when in her hospital room, just after her tonsillectomy, he had brought her a splendid kaleidoscope. When are they going to do the operation? She had asked a little sleepily. They've already done it, Stoughton had answered her. You're going to be fine. She found it disquieting that the whole blocks of time could be stolen without her knowledge. She blamed him. She knew at the time it was childish. That her mother could truly love him was inconceivable. She must have remarried out of loneliness, out of weakness. She needed someone to take care of her. Ellie vowed she would never accept a position of dependence. Ellie's father had died. Her mother had grown distant, and Ellie felt herself exiled to the house of a tyrant. There was no one to call her Presh anymore. She longed to escape. Bridgeport, said I. Camelot, said he. Chapter 2. Coherent Life. Since I first gained the use of reason, my inclination towards learning had been so violent and strong that neither the scoldings of other people nor my own reflections have been able to stop me from following this natural impulse that God gave me. He alone must know why, and he knows too that I have begged him to take away the light of my understanding, leaving only enough for me to keep his law, for anything else is excessive in a woman, according to some people, and others say it is even harmful. Juana Inés de la Cruz replied to the Bishop of Puebla, who had attacked her scholarly work as inappropriate for her sex. I wish to propose for the reader's favorable consideration a doctrine which may, I fear, appear wildly paradoxical and subversive. The doctrine in question is this, that it is undesirable to believe a proposition when there is no ground whatever for supporting it true. I must, of course, admit that if such an opinion became common, it would completely transform our social life and our political system, since both are at present faultless. This must weigh against it. Bertrand Russell, Skeptical Essay, number 1, 1928. Surrounding the blue-white star in its equatorial plane was a vast ring of orbiting debris, rocks and ice, metals and organics, reddish at the periphery and bluish closer to the star. The world-sized polyhedron plummeted through a gap in the rings and emerged on the other side. In the ring plane, it had been intermittently shadowed by icy boulders and tumbling mountains, but now carried along at its trajectory towards a point above the opposite pole of the star. The sunlight gleamed off its millions of bowl-shaped appendages. If you looked very carefully, you might have seen one of them make a slight pointing adjustment. You would not have seen the burst of radio waves washing out from it into the depths of space. For all the tenure of humans on Earth, the night sky had been a companion and an inspiration. The stars were comforting. They seemed to demonstrate that the heavens were created for the benefit and instruction of humans. This pathetic conceit became the conventional wisdom worldwide. No culture was free of it. Some people found in the skies an aperture to their religious sensibility. Many were awestruck and humbled by the glory and scale of the cosmos. Others were stimulated to the most extravagant flights of fancy. At the very moment that humans discovered the scale of the universe and found that their most unconstrained fancies were in fact dwarfed by the true dimensions of even the Milky Way galaxy, they took steps that ensured that their descendants would be unable to see the stars at all. For 1,000,000 years, humans had grown up with a personal daily knowledge of the vault of heaven. In the last few thousand years, they began building and emigrating to the cities. In the last few decades, a major fraction of the human population had abandoned a rustic way of life. As technology developed and the cities were polluted, the nights became starless. New generations grew to maturity wholly ignorant of the sky that had transfixed their ancestors and that had stimulated the modern age of science and technology. Without even noticing, just as astronomy entered a golden age, most people cut themselves off from the sky, a cosmic isolationism that ended only with the dawn of space exploration. Ellie would look up at Venus and imagine it was a world something like the Earth, populated by plants and animals and civilizations, but each of them different from the kinds we have here. On the outskirts of town, just after sunset, she would examine the night sky and scrutinize that unflickeringly bright point of light. By comparison with nearby clouds just about above her, still illuminated by the sun, it seemed a little yellow. She tried to imagine what was going on there. She would stand on tiptoe and stare the planet down. Sometimes she could almost convince herself that she could really see it. A swirl of yellow fog would suddenly clear, and a vast jeweled city would briefly be revealed. Air cars sped among the crystal spires. Sometimes she would imagine peering into one of those vehicles and glimpsing one of them. Or she would imagine a young one glancing up at a bright blue point of light in its sky, standing on tiptoe and wondering about the inhabitants of Earth. It was an irresistible notion, a sultry tropical planet brimming over with intelligent life and just next door. She consented to rote memorization, but she knew that it was at best the hollow shell of an education. She did the minimum work necessary to do well in her courses and pursued other matters. She arranged to spend free periods and occasional hours after school in what was called shop, a dingy and cramped small factory established when the school devoted more effort to vocational education than was now fashionable. Vocational education meant more than anything else, working with your hands. There were lathes and drill presses and other machine tools, which she was forbidden to approach because no matter how capable she might be, she was still a girl. Reluctantly, they granted her permission to pursue her own projects in the electronics area of the shop. She built radios more or less from scratch, and then went on to something more interesting. She built an encrypting machine. It was rudimentary, but it worked. It could take any English language message and transform it by a simple substitution cipher into something that looked like gibberish. Building a machine that would do the reverse, converting an encrypted message into clear when you didn't know the substitution conversion, now that was harder. You could have the machine run through all the possible substitutions. A stands for B, A stands for C, A stands for D, or you could remember that some letters in English were used more often than others. You could get some idea of the frequency of letters by looking at the sizes of the bins for each letter of type in the print shop next door. ETAOINSHRDLU, the boys in print shop would say, giving pretty closely the order of the 12 most frequently used letters in English. In decoding a long message, the letter that was most common probably stood for an E. Certain consonants tended to go together, she discovered. Vowels distributed themselves more or less at random. The most common 3-letter word in the language was the. If within a word there was a letter standing between a T and an E, it was almost certainly H. If not, you could bet on R or a vowel. She deduced other rules and spent long hours counting up the frequency of letters in various school books before she discovered that such frequency tables had already been compiled and published. Her decrypting machine was only for her own enjoyment. She did not use it to convey secret messages to friends. She was unsure to whom she might safely confide these electronic and cryptographic interests. The boys became jittery or boisterous, and the girls looked at her strangely. Soldiers of the United States were fighting in a distant place called Vietnam. Every month, it seemed, more young men were being scooped off the street or the farm and packed off to Vietnam. The more she learned about the origins of the war and the more she listened to the public pronouncement of national leaders, the more outraged she became. The president and the Congress were lying and killing, she thought to herself, and almost everyone was merely assenting. The fact that her stepfather embraced official positions on treaty obligations, dominoes, and naked communist aggression only strengthened her resolve. She began attending meetings and rallies at the college nearby. The people she met there seemed much brighter, friendlier, more alive than her awkward, lusterless high school companions. John Stanton first cautioned her and then forbade her to spend time with college students. They would not respect her, he said. They would take advantage of her. She was pretending to a sophistication she did not have and never would. Her style of dress was deteriorating. Military fatigues were inappropriate for a girl, a travesty, a hypocrisy for someone who claimed to oppose the American intervention in Southeast Asia. Beyond pious exhortations to Ellie, and Stanton not to fight, her mother participated little in these discussions. Privately, she would plead with Ellie to obey her stepfather, to be nice. Ellie now suspected Stanton of marrying her mother for her father's life insurance. Why else? He certainly showed no sign of loving her, and he was not predisposed to be nice. One day, in some agitation, her mother asked her to do something for all their sakes, attend Bible class. While her father, a skeptic on revealed religions, had been alive, there was no talk of Bible class. How could her mother have married Stanton? The question welled up in her for the 1000th time. Bible class, her mother continued, would help her instill the conventional virtues. But even more important, it would show Stanton that Ellie was willing to make some accommodation. Out of love and pity for her mother, she acquiesced. So every Sunday for most of 1 year, Ellie went to a regular discussion group at a nearby church. It was one of the respectable Protestant denominations, untainted by disorderly evangelism. There were a few high school students, a number of adults, mainly middle-aged women, and the instructor, the minister's wife. Ellie had never seriously read the Bible before and had been inclined to accept her father's perhaps ungenerous judgment that it was half barbarian history, half fairy tales. So over the next week, preceding her first class, she read through what seemed to be the important parts of the Old Testament, trying to keep an open mind. She once recognized that there were two different and mutually contradictory stories of creation in the first 2 chapters of Genesis. She did not see how there could be light and days before the sun was made, and had trouble figuring out exactly who it was that Cain had married. In the stories of Lot and his daughters, of Abraham and Sarah in Egypt, and of the betrothal of Dinah, of Jacob and Esau, she found herself amazed. She understood that cowardice might occur in the real world, that sons might deceive and defraud an aged father, that a man might give craven consent to the seduction of his wife by the king, or even encourage the rape of his daughters. But in this holy book, there was not a word of protest against such outrages. Instead, it seemed the crimes were approved, even praised. When class began, she was eager for a discussion of these vexing inconsistencies, for an unburdening illumination of God's purpose, or at least for an explanation of why these crimes were not condemned by the author. But in this she was disappointed. The minister's wife blandly temporized. Somehow these stories never surfaced in subsequent discussion. When Ellie inquired how it was possible for the maidservant of the daughter of Pharaoh to tell just by looking at the baby in the bulrushes that he was Hebrew, the teacher blushed deeply and asked Ellie not to raise unseemly questions. The answer dawned on Ellie at that moment. When they came to the New Testament, Ellie's agitation increased. Matthew and Luke traced the ancestral line of Jesus back to King David, but for Matthew there were 28 generations between David and Jesus, for Luke 43. There were almost no names common to the two lists. How could both Matthew and Luke be the Word of God? The contradictory genealogies seemed to Ellie a transparent attempt to fit this Isaiah prophecy after the event. Cooking the data, it was called in a chemistry lab. She was deeply moved by the Sermon on the Mount. deeply disappointed by the admonition to render unto Caesar's what is Caesar's, and reduced to shouts and tears after the instructor twice sidestepped her questions on the meaning of "I bring not peace but the sword." She told her despairing mother that she had done her best, but wild horses wouldn't drag her to another Bible class. She was lying on her bed. It was a hot summer's night. Elvis was singing "One Night with You, That's What I'm Begging For." The boys at the high school seemed painfully immature, and it was difficult, especially with her stepfather's strictures and curfews, to establish much of a relationship with the young college men she met at lectures and rallies. John Stanton was right, she reluctantly admitted to herself, at least about this. The young men, almost without exception, had a penchant for sexual exploitation. At the same time, they seemed much more emotionally vulnerable than she had expected. Perhaps the one caused the other. She had half expected not to attend college, although she was determined to leave home. Staunton would not pay for her to go elsewhere, and her mother's meek intercessions were unavailing. But Ellie had done spectacularly well on the standardized college entrance exam, and found to her surprise her teachers telling her that she was likely to be offered scholarships by well-known universities. She had guessed on a number of multiple-choice questions and considered her performance a fluke. If you know very little, only enough to exclude all but the two most likely answers, and if you then guess at 10 straight questions, there's about 1 chance in 1,000, she explained to herself, that you'll get 10 correct answers. For 20 straight questions, the odds were 1 in 1,000,000, but something like 1,000,000 kids probably took this test. Someone had to get lucky. Cambridge, Massachusetts seemed far enough away to elude John Stanton's influence, but close enough to return from on vacation to visit her mother, who viewed the arrangement as a difficult compromise between abandoning her daughter and incrementally irritating her husband. Ellie surprised herself by choosing Harvard over Massachusetts Institute of Technology. She arrived for orientation period a pretty, dark-haired young woman of middling height, with a lopsided smile and an eagerness to learn everything. She set out to broaden her education, to take as many courses as possible apart from her central interests in mathematics, physics, and engineering. But there was a problem with her central interests. She found it difficult to discuss physics, much less debate it, with her predominantly male classmates. At first, they paid a kind of selective inattention to her remarks. There would be a slight pause, and then they would go on as if she had not spoken. Occasionally, they would acknowledge her remark, even praise it, and then again continue and deflect it. She was reasonably sure her remarks were not entirely foolish, and did not wish to be ignored, much less ignored and patronized alternately. Part of it, but only part, she knew, was due to the softness of her voice. So she developed a physics voice, a professional voice, clear, competent, and many decibels above conversational. With such a voice, it was important to be right. She had to pick her moments. It was hard to continue long in such a voice, because she was sometimes in danger of bursting out laughing. So she found herself leaning towards quick, sometimes cutting interventions, usually enough to capture their attention. Then she could go on for a while in a more usual tone of voice. Every time she found herself in a new group, she would have to fight her way through again, just to dip her oar into the discussion. The boys were uniformly unaware even that there was a problem. Sometimes she would be engaged in a laboratory exercise or a seminar when the instructor would say, "Gentlemen, let's proceed," and scenting Ellie's frown would say, "Sorry, Miss Arroway, but I think of you as one of the boys." The highest compliment they were capable of paying was that, in their minds, she was not overtly female. She had to fight against developing too combative a personality or becoming altogether a misanthrope. She suddenly caught herself. Misanthrope is someone who dislikes everybody, not just men, and they certainly had a word for someone who hates men, misogynist, or someone who hates women, misogynist. But the male lexicographers had somehow neglected to coin a word for dislike of men. They were almost entirely men themselves, she thought, and had been unable to imagine a market for such a word. More than many others, she had been encumbered with parental proscriptions. Her newfound freedom, intellectual, social, sexual, was exhilarating. At a time when many of her contemporaries were moving towards shapeless clothing that minimized the distinctions between the sexes, she aspired to an elegance and simplicity of dress and makeup that strained her limited budget. There were more effective ways to make political statements, she thought. She cultivated a few close friends and made a number of casual enemies who disliked her for her dress, for her political and religious views, or for the vigor with which she defended her opinions. Her competence and delight in science were taken as rebukes by many otherwise capable young women, but a few looked on her as what mathematicians call an existence theorem, a demonstration that a woman could, sure enough, excel in science or even as a role model. At the height of the sexual revolution, she experimented with gradually increasing enthusiasm, but found she was intimidating her would-be lovers. Her relationships tended to last a few months or less. The alternative seemed to be to disguise her interest and stifle her opinions, something she had resolutely refused to do in high school. The image of her mother, condemned to a resigned and placatory imprisonment, haunted Ellie. She began to wondering about men unconnected with the academic and scientific life. Some women, it seemed, were entirely without guile and bestowed their affections with hardly a moment's conscious thought. Others set out to implement a campaign of military thoroughness with branched contingency trees and fallback positions, all to catch a desirable man. The word desirable was the giveaway, she thought. The poor jerk wasn't actually desired, only desirable, a plausible object of desire in the opinion of those others on whose account this whole sorry charade was performed. Most women, she thought, were somewhere in the middle, seeking to reconcile their passions with their preconceived long-term advantage. Perhaps there were occasional communications between love and self-interest that escaped the notice of the conscious mind, but the whole idea of calculated entrapment made her shiver. In this matter, she decided she was a devotee of the spontaneous. That was when she met Jessie. Her date had taken her to a cellar bar off Kenmore Square. Jessie was singing rhythm and blues and playing lead guitar. The way he sang and the way he moved made clear what she had been missing. The next night she returned alone. She seated herself at the nearest table and locked eyes with him through both his sets. 2 months later they were living together. It was only when his bookings took him to Hartford or Bangor that she got any work done at all. She would spend her days with the other students, boys with the final generation of slide rules hanging like trophies from their belts, boys with plastic pencil holders in their breast pockets, precise, stilted boys with nervous laughs, serious boys spending all their waking moments becoming scientists, absorbed in training themselves to plumb the depths of nature. They were almost helpless in ordinary human affairs, where for all their knowledge they seemed pathetic and shallow. Perhaps the dedicated pursuit of science was so consuming, so competitive, that no time was left to become a well-rounded human being, or perhaps their social disabilities had led them to fields where the want would not be noticed. Except for science itself, she did not find them good company. At night there was Jessie, leaping and wailing, a kind of force of nature that had taken over her life. In the year they spent together, she could not recall a single night when he proposed they go to sleep. He knew nothing of physics or mathematics, but he was wide awake inside the universe, and for a time so was she. She dreamed of reconciling her two worlds. She had fantasies of musicians and physicists in harmonious social concert. But the evenings she organized were awkward and ended badly. One day he told her he wanted a baby. He would be serious. He'd settle down. He'd get a regular job. He might even consider marriage. A baby, she asked him. But I'd have to leave school. I've years more before I'm done. If I had a baby, I might never go back to school. Yeah, he said, but we'd have a baby. You wouldn't have school, but you'd have something else. Jessie, I need school, she told him. He shrugged. She could feel their lives together slip off his shoulders and away. It lasted another few months, but it had all really been settled in that brief exchange. They kissed each other goodbye, and he went off to California. She never heard his voice again. In the late 1960s, the Soviet Union succeeded in landing space vehicles on the surface of Venus. They were the first spacecraft of the human species to set down in working order on another planet. Over a decade earlier, American radio astronomers confined to Earth had discovered that Venus was an intense source of radio emission. The most popular explanation had been that the massive atmosphere of Venus trapped the heat through a planetary greenhouse effect. In this view, the surface of the planet was stifling hot, much too hot for crystal cities and wandering Venusians. Ellie longed for some other explanation and tried unsuccessfully to imagine ways in which the radio emissions could come from high above a clement Venus surface. Some astronomers at Harvard and MIT claimed that none of the alternatives to a broiling Venus could explain the radio data. The idea of so massive a greenhouse effect seemed to her unlikely and somehow distasteful. A planet that had let itself go. But when the Venera spacecraft landed and in effect stuck out a thermometer, the temperature measured was high enough to melt tin or lead. She imagined the crystal cities liquefying, although Venus wasn't quite that hot. The surface awash in silicate tears. She was a romantic. She had known it for years. But at the same time, she had to admire how powerful radio astronomy was. The astronomers had sat home, pointed their radio telescopes at Venus, and measured the surface temperature just about as accurately as the Venera probe did 13 years later. She had been fascinated with electricity and electronics as long as she could remember, but this was the first time she had been deeply impressed by radio astronomy. You stay safely on your own planet and point your telescope with its associated electronics. Information about other worlds then comes fluttering down through the feeds. She marveled at the notion. Ellie began to visit the university's modest radio telescope in nearby Harvard, Massachusetts, eventually getting an invitation to help with the observations and the data analysis. She was accepted as a paid summer assistant at the National Radio Astronomy Observatory in Green Bank, West Virginia, and upon arrival gazed in some rapture at Grote Reber's original radio telescope, constructed in his backyard in Wheaton, Illinois in 1938, and now serving as a reminder of what a dedicated amateur can accomplish. Reber had been able to detect the radio emissions from the center of the galaxy when no one nearby happened to be starting up the car. And the diathermy machine down the street was not in operation. The galactic center was much more powerful, but the diathermy machine was a lot closer. The atmosphere of patient inquiry and the occasional rewards of modest discovery were agreeable to her. They were trying to measure how the number of distant extragalactic radio sources increased as they looked deeper into space. She began to think about better ways of detecting faint radio signals. In due course, she graduated cum laude from Harvard and went on for graduate work in radio astronomy at the other end of the country, at the California Institute of Technology. For a year, she apprenticed herself to David Drumlin. He had a worldwide reputation for brilliance and for not suffering fools gladly, but was at heart one of those men you can find at the top of every profession who are in a state of unrelieved anxiety that someone else somewhere might prove smarter than they. Drumlin taught Ellie some of the real heart of the subject, especially in its theoretical underpinnings. Although he was inexplicably rumored to be attracted to women, Ellie found him frequently combative and unremittingly self-involved. He was too romantic, he would say. The universe is strictly ordered according to its own rules. The idea is to think as the universe does, not to foist our own romantic predispositions and girlish longings, he once said, on the universe. Everything not forbidden by the laws of nature, he assured her, quoting a colleague down the hall, is mandatory. But he went on, almost everything is forbidden. She gazed at him as he lectured, trying to divine the odd combination of personality traits. She saw a man in excellent physical condition, prematurely gray, sardonic smile, half-moon reading glasses perched toward the end of his nose, bow tie, square jaw, and remnants of a Montana twang. His idea of a good time was to invite the graduate students and junior faculty over for dinner, unlike her stepfather, who enjoyed a student entourage but considered having them to dinner an extravagance. Drumlin would exhibit an extreme intellectual territoriality, steering the conversation to topics in which he was the acknowledged expert, and then swiftly dispatching contrary opinions. After dinner, he would often subject them to a slideshow of Dr. D scuba diving in Cozumel, or Tobago, or the Great Barrier Reef. He was often smiling into the camera and waving, even in the underwater images. Sometimes there would be a submarine vista of his scientific colleague, Dr. Helga Bork. Drumlin's wife would always object to these particular slides on the reasonable grounds that most of the audience had already seen them at previous dinner parties. In truth, the audience had already seen all the slides. Drumlin would respond by extolling the virtues of the athletic Dr. Bork, and his wife's humiliation increased. Many of the students gamely went along, seeking some novelty they had previously missed among the brain corals and the spiny sea urchins. A few would writhe in embarrassment or become absorbed by the avocado dip. A stimulating afternoon for his graduate students would be for them to be invited over in twos and threes to drive him to the edge of a favorite cliff near Pacific Palisades. Casually attached to his hang glider, he would leap off the precipice towards the tranquil ocean a few hundred feet below. Their job was to drive down the coast road and retrieve him. He would swoop down upon them, beaming exultantly. Others were invited to join him, but few accepted. He had and delighted in the competitive advantage. It was quite a performance. Others looked on graduate students as resources for the future, as their intellectual torchbearers to the next generation, but Drumlin, she felt, had quite a different view. For him, graduate students were gunslingers. There was no telling which of them might at any moment challenge him for the reigning title of the fastest gun in the West. They were to be kept in their places. He never made a pass at her, but sooner or later she was certain he was bound to try. In her second year at Caltech, Peter Valerian returned to campus from his sabbatical year abroad. He was a gentle and unprepossessing man. No one, least of all himself, considered him especially brilliant. Yet he had a steady record of significant accomplishment in radio astronomy because, he explained, when pressed, he kept at it. There was one slightly disreputable aspect of his scientific career. He was fascinated by the possibility of extraterrestrial intelligence. Each faculty member, it seemed, was allowed one foible. Drumlin had hang gliding. Valerian had life on other worlds. Others had topless bars or carnivorous plants or something called transcendental meditation. Valerian had thought about extraterrestrial intelligence, abbreviated ETI, longer and harder, and in many cases more carefully than anyone else. As she grew to know him better, it seemed that ETI provided a fascination, a romance, that was in dramatic contrast with the humdrum business of his personal life. This thinking about extraterrestrial intelligence was not working for him, but play. His imagination soared. Ellie loved to listen to him. It was like entering Wonderland or the Emerald City. Actually, it was better because at the end of all his ruminations, there was the thought that maybe this could really be true, could really happen. Someday, she mused, there might, in fact, not just in fantasy, be a message received by one of the great radio telescopes. But in a way it was worse because Valerian, like Drumlin on other subjects, repeatedly stressed that speculation must be confronted with a sober physical reality. It was a kind of sieve that separated the rare useful speculation from torrents of nonsense. The extraterrestrials and their technology had to conform strictly to the laws of nature, a fact that severely crimped many a charming prospect. But what emerged from the sieve and survived the most skeptical physical and astronomical analysis might even be true. You couldn't be sure, of course. There were bound to be possibilities that you had missed, that people cleverer than you would one day figure out. Valerian would emphasize how we are trapped by our time and culture, our biology, how limited we are by definition in imagining fundamentally different creatures or civilizations, and separately evolving on a very different world. They would have to be very different than us. It was possible that beings much more advanced than we might have unimaginable technologies. This was in fact almost guaranteed, and even new laws of physics. It was hopelessly narrow-minded, he would say, as they walked past a succession of stucco arches, as in de Chirico's paintings, to imagine that all significant laws of physics had been discovered at the moment our generation began contemplating the problem. There would be 21st century physics and 22nd century physics, and even a fourth millennium physics. We might be laughably far off in guessing how very different technical civilization would communicate. But then he always reassured himself that extraterrestrials would have to know how backward we were. If we were any more advanced, they would know about us already. Here we were, just beginning to stand up on our 2 feet, discovering fire last Wednesday and only yesterday stumbling on Newtonian dynamics, Maxwell's equations, radio telescopes, and hints of superunification of the laws of physics. Valerian wasn't sure they wouldn't make it hard for us. They would try to make it easy because if they wanted to communicate with dummies, they would have to make allowances for the dummies. That's why he thought he'd have a fighting chance if a message ever came. His lack of brilliance was, in fact, his strength. He knew he was confident. What dummies knew. As a topic for her doctoral thesis, Ellie chose, with the concurrence of the faculty, the development of an improvement in the sensitive receivers employed on radio telescopes. It made use of her talents in electronics, freed her from the mainly theoretical drumlin, and permitted her to continue her discussions with Valerian, but without taking the professionally dangerous step of working with him on extraterrestrial intelligence. It was too speculative a subject for a doctoral dissertation. Her stepfather had taken to denouncing her various interests as unrealistically ambitious, or occasionally as deadeningly trivial. When he heard of her thesis topic, through the grapevine, by now she was not talking to him at all, he dismissed it as pedestrian. She was working on the ruby master. A ruby is made mainly of alumina, which is almost perfectly transparent. The red color derives from a small chromium impurity distributed throughout the alumina crystal. When a strong magnetic field is impressed on the ruby, the chromium atoms increase their energy, or as physicists like to say, are raised to an excited state. She left the image of all the little chromium atoms called to feverish activity in each amplifier, frenzied in a good practical cause, amplifying a weak radio signal. The stronger the magnetic field, the more excited the chromium atoms became. Thus, the maser could be tuned so that it was particularly sensitive to a selected radio frequency. She found a way to make rubies with lanthanide impurities in addition to the chromium atoms, so a maser could be turned to a narrower frequency range and could detect a much weaker signal than previous masers. Her detector had to be immersed in liquid helium. She then installed her new instrument on one of Caltech's radio telescopes in Owens Valley and detected an entirely new frequency, what astronomers call the 3-degree blackbody background radiation, the remnant in the radio spectrum of the immense explosion that began in the universe, the Big Bang. Let's see if I got this right, she would say to herself. I've taken an inert gas that's in the air, made it into a liquid, put some impurities into a ruby, attached a magnet, and detected the fires of creation. She would then shake her head in amazement. To anyone ignorant of the underlying physics, it might seem the most arrogant and pretentious necromancy. How would you explain this to the best scientists of 1,000 years ago who knew about air and rubies and lodestones, but not about liquid helium, stimulated emission, and superconducting flux pumps? In fact, she reminded herself, they did not have even the foggiest notion about the radio spectrum, or even the idea of a spectrum, except vaguely from contemplating the rainbow. They did not know that light was waves. How could we hope to understand the signs of civilization 1,000 years ahead of us? It was necessary to make rubies in large batches, because only a few would have the requisite properties. None were quite a gemstone quality, and most were tiny, but she took to wearing a few of the larger remnants. They matched her dark coloring well. Even if it was carefully cut, you could recognize some anomaly in the stone set in a ring or a brooch. The odd way, for example, that it caught the light at certain angles from an abrupt internal reflection, or a peach-colored blemish inside the ruby red. She would explain to non-scientist friends that she liked rubies but couldn't afford them. It was a little like the scientist who first discovered the biochemical pathway of green plant photosynthesis and who forever after wore pine needles or a sprig of parsley in his lapel. Colleagues, their respect for her growing, considered it a minor idiosyncrasy. The great radio telescopes of the world are constructed in remote locations for the same reason Paul Gauguin sailed to Tahiti. For them to work well, they must be far from civilization. As civilian and military radio traffic had increased, radio telescopes have had to hide, sequestered in an obscure valley in Puerto Rico, say, or exiled to a vast scrub desert in New Mexico or Kazakhstan. As radio interference continues to grow, it makes increasing sense to build the telescopes off the Earth altogether. The scientists who work at these isolated observatories tend to be dogged and determined. Spouses abandon them, children leave home at the first opportunity, but the astronomers stick it out. Rarely do they think of themselves as dreamers. The permanent scientific staff in remote observatories tend to be the practical ones. The experimentalists, the experts who know a great deal about antenna design and data analysis and much less about quasars and pulsars. Generally speaking, they had not longed for the stars in childhood. They had been too busy repairing the carburetor in the family car. After receiving her doctorate, Ellie accepted an appointment as a research associate at the Arecibo Observatory, a great bowl 305 meters across, fixed to the floor of the Karst Valley in the foothills of northwest Puerto Rico. With the largest radio telescope on the planet, she was eager to employ her maser detector, to look at many different astronomical objects as she could, nearby planets and stars, the center of the galaxy, pulsars and quasars. As a full-time member of the observatory staff, she would be assigned a significant amount of observing time. Access to the great radio telescopes is keenly competitive, there being many more worthwhile projects than can possibly be accommodated. So reserved telescope time for the resident staff is a perquisite beyond price. For many of the astronomers, it was the only reason they would consent to live in such God-forsaken places. She also hoped to examine a few nearby stars for possible signals of intelligent origin. With her detector system, it would be possible to hear the radio leakage from a planet like Earth, even if it was a few light years away. An advanced society intending to communicate with us would doubtless be capable of much greater power transmission than we were. If Arecibo, used as radar telescope, was capable of transmitting 1 megawatt of power to a specific locale in space, then a civilization only a little bit in advance of ours might, she thought, be capable of transmitting 100 megawatts or more. If they were intentionally transmitting to the Earth with a telescope as large as Arecibo, but with a 100 megawatt transmitter, Arecibo should be able to detect them virtually anywhere in the Milky Way galaxy. When she thought carefully about it, she was surprised that in the search for extraterrestrial intelligence, what could be done was so far ahead of what had been done. The resources that had been devoted to this question were trifling, she thought. She was hard-pressed to name a more important scientific problem. The Arecibo facility was known to the locals as El Radar. Its function was generally obscure, but it provided more than 100 badly needed jobs. The indigenous young women were sequestered from the male astronomers, some of whom could be viewed at almost any time of day or night, full of nervous energy, jogging along the circumferential track that surrounded the dish. As a result, the attention directed at Ellie upon her arrival, while not entirely unwelcome, soon became a distraction for her research. The physical beauty of the place was considerable. At twilight, she would look out the control windows and see storm clouds hovering over the other lip of the valley, just beyond one of 3 immense pylons, from which the feed horns and her newly installed maser system were suspended. At the top of each pylon, a red light would flash to warn off any airplanes that had improbably strayed upon the remote vista. At 4 a.m., she would step outside for a breath of air and puzzle to understand a massed chorus of thousands of local land frogs called coquilles, in imitation of their plaintive cry. Some astronomers lived near the observatory, but the isolation compounded by ignorance of Spanish and the inexperience with any other culture tended to drive them and their wives towards loneliness and ennui. Some had decided to live at Ramey Air Force Base, which boasted the only English language school in the vicinity, but the 90-minute drive also heightened their sense of isolation. Repeated threats by Puerto Rican separatists, convinced erroneously that the observatory played some significant military function, increased the sense of subdued hysteria of circumstances barely under control. Many months later, Valerian came to visit. Normally he was there to give a lecture, but she knew that part of his purpose was to check up on how she was doing and provide some semblance of psychological support. Her research had gone very well. She had discovered what seemed to be a new interstellar molecular cloud complex and had obtained some very fine high time resolution data on the pulsar at the center of the Crab Nebula. She had even completed the most sensitive search yet performed for signals from a few dozen nearby stars, but with no positive results. There had been one or two suspicious regularities. She observed the stars in question again and could find nothing out of the ordinary. Look at enough stars and sooner or later terrestrial interference or the concatenation of some random noise will produce a pattern that for a moment makes your heart palpitate. You calm down and check it out. If it doesn't repeat itself, you consider it spurious. This discipline was essential if she was to preserve some emotional equilibrium in the face of what she was seeking. She was determined to be as tough-minded as possible, without abandoning the sense of wonder that was driving her in the first place. From her scant supply in the community refrigerator, she had made a rudimentary picnic lunch, and Valerian sat with her along the very periphery of the bowl-shaped dish. Workmen repairing or replacing the panels could be seen in the distance, walking on special snowshoes so they did not tear the aluminum sheets and plunge through the ground below. Valerian was delighted with her progress. They exchanged bits of gossip and current scientific tidbits. The conversation turned to SETI, as the search for extraterrestrial intelligence was beginning to be called. "Have you ever thought about doing it full-time, Ellie?" he asked. "I haven't thought about it much, but it's not really possible, is it? There's no major facility devoted to SETI full-time anywhere in the world, as far as I know." "No, but there might be. There's a chance that dozens of additional dishes might be added to the very large array and make it into a dedicated SETI observatory. They do some of the usual kind of radio astronomy, of course. It would be a superb interferometer. It's only a possibility. It's expensive. It needs real political will, and it's years away at best. Just something to think about." "Peter, I've just examined some 40-odd nearby stars of roughly solar spectral type. I've looked in the 21-centimeter hydrogen line, which everyone says is the obvious beacon frequency, because hydrogen is the most abundant atom in the universe and so on. And I've done it with the highest sensitivity ever tried. There's not a hint of a signal. Maybe there's not one out there. Maybe the whole business is a waste of time." "Like life on Venus? That's just disillusionment talking. Venus is a hellhole of a world. It's just one planet. But there's hundreds of billions of stars in the galaxy. You've looked at only a handful. Wouldn't you say it's a little premature to give up? You've done 1/1000th of the problem, probably much less than that, if you consider other frequencies." I know. But don't you have the sense that if they're anywhere, they're everywhere? If really advanced guys live 1,000 light years away, shouldn't they have an outpost in our backyard? You could do the SETI thing forever, and never convince yourself that you'd completed the search. "Oh, you're beginning to sound like Dave Drumlin. If we can't find them in his lifetime, he's not interested. We're just beginning SETI. You know how many possibilities there are. This is the time to leave every option open. This is the time to be optimistic. If we lived in any previous time in human history, we could wonder about this all our lives, and we couldn't do a thing to find the answer. But this time is unique. This is the first time when anybody's been able to look for extraterrestrial intelligence. You've made the detector to look for civilizations on the planets of millions of other stars. Nobody's guaranteeing success. But can you think of a more important question? Imagine them out there sending us signals and nobody on Earth listening. That would be a joke and a travesty. Wouldn't you be ashamed of your civilization if we were able to listen and we didn't have the gumption to do it? 256 images of the left world swam by on the left. 256 images of the right world glided by on the right. He integrated all 512 images in a wraparound view of his surroundings. He was deep in a forest of great waving blades, some green, some etiolated, almost as large as he. But he had no difficulty clambering up and over, occasionally balancing precariously on a bent blade, falling to the gentle cushion of horizontal blades below, and then continuing unerringly on his journey. He could tell he was centered on the trail. It was tantalizingly fresh. He would think nothing. If that's where the trail led, of scaling an obstacle 100 or 1,000 times as tall as he was, he'd need no pylons or ropes. He was already equipped. The ground immediately before him was redolent with a marker odor left recently. It must be by another scout of his clan. It would lead to food. It almost always did. The food would spontaneously appear. Scouts would find it and mark the trail. He and his fellows would bring it back. Sometimes the food was a creature rather like himself. Other times it was only an amorphous or crystalline lump. Occasionally it was so large that many of his clan would be required, working together, heaving and shoving it over forced blades to carry it home. He smacked his mandibles in anticipation. What worries me most, she continued, is the opposite. The possibility that they're not trying. They could communicate with us all right, but they're not doing it because they don't see any point to it. It's like, she glanced down at the edge of the tablecloth they had spread over the grass, like the ants. They occupy the same landscape that we do. They have plenty to do, things to occupy themselves. On some level, they're very well aware of their environment, but we don't try to communicate with them. So I don't think they have the foggiest notion that we exist. A large ant, more enterprising than his fellows, had ventured onto the tablecloth and was briskly marching along the diagonal of one of the red and white squares. Suppressing a small twinge of revulsion, she gingerly flicked it back off to the grass, where it belonged.